to these videos about air navigation. In this video, I will present an introduction to surveillance. The main reference we are using is, as we can see here in the corner, is the chapter 4 of the reference we are using in the course, the Introduction to Air Navigation book. And first, we should start with a definition of what is surveillance. Surveillance is one of the pillars that support the CNS concept. And as you see over here, there is an S. This S means surveillance. Okay. So the surveillance concept is just basically watching closely in one area. Okay. So this means that, sorry, I want to draw here like an air traffic controller screen or some area in the airspace. And typically what you want to do is just to identify the location of the different objects. For us, those objects are aircraft, okay, and typically the provision of knowledge regarding aircraft position is referred to as surveillance, okay? So we want to define, determine, or acquire those aircraft locations. So to provide the three basic air ATS services, the alert, information, and control that we will gonna see in the chapter 7, a reliable surveillance system is required. So from this surveillance system, we can obtain the following information. So some fundamental data. Okay, here some fundamental data. Obviously, the aircraft position, the identification, and the altitude. This is quite mandatory to understand, yeah, the position and who is who, right? So, and there are also other information that we can acquire from some surveillance systems, such as the aircraft direction, speed, rate of climb. Okay, and how was surveillance initially done? Okay, in the past. So we have the typical visual observation. So you see here this lady with monoculars just watching the airport or the vicinities areas around the airport in order to identify if there are traffic coming or departing. Of course, right now this is also done in some aerodrome context. Okay, so this is typically done as you see here. This is a control tower. Okay, and this is still done. Okay, and before so long time ago, before the Second World War, it was surveillance was done through noise detection. As you see, it was big artifact like this, and one guy just using putting this tool into the airs and turning and moving the direction in order to keep to get the noise coming from the aircraft in the surrounded areas. And finally, through communication reports, so the pilots yes, notify to the air traffic controller the position using the radio. And this is what is typically called procedural air traffic control techniques, okay? And it's done through the flight progress scripts, as you see here, okay? This is a complex technique. There is color for is selected for one kind of flights, and also here you can see certain notification points and important points. And in these flight scripts, the flight plan, the route it contains the route of the plane with the altitude and estimated times over reporting points. Okay, and then when the notification appears, the traffic controller is reading here the information, and then this is the way the traffic controller is getting an idea of how the traffic is organized. Okay, obviously this procedure keeps as a backup technique if the current techniques are failing. Okay, it's as always in aviation, safety first, and you have like the traditional procedures as backups, and all your staff are prepared to use them in case of needs of necessity. So the different technology we have. We already mentioned the procedural separation. I didn't mention before, but it's important to remark that is inaccurate. Okay, of course, there are is less accurate than others, because also you only get the ASAMA updates in the position when the pilot notifies or contact you. Okay, contact the traffic controller. And also, it's possible that in this communication, it can be possible some kind of some misunderstandings in this communication. Okay, and the second one, and is the more frequently used, the surveillance operation. Okay, is accurate, and also you can trust because you can see the the aircraft in the air traffic controller display. Okay, you get some track with a stamp with the information of this flight and also the flight plan. So it's like you can trust more in the information that you are getting in real time. Okay, this is not just how you are guessing when this aircraft is expecting to arrive. No, no, no. You see in the screen where your plane is, and also the more magnitudes, such as speed, other things. Okay, and there are different types. You have the radar techniques, the primary surveillance radar and secondary surveillance radar. Basically very quickly, but don't worry, because those we are going to cover all of them. Yeah, the two of them in later on. Okay, in next video and the following one. So it's just you interrogate, you propagate a signal. Okay, and then you get some response or some echo. Okay, depending of if you're using a primary surveillance radar or a secondary surveillance radar, and the distance. Okay, you get here the north, and this is another view. Okay, so what you get is the azimuth. Okay, this angle over here, and this distance. Okay, so I think all of you are familiarized with this radar thing, okay? ADSB. ADSB is a more recently system, okay? It stands for ADSB. ADS stands for Automatic Dependent Surveillance, and there are two systems, okay? ADSB, B is from broadcast, and C from contract, okay? Again, very briefly, broadcast is the aircraft as is allocates a transponder, so it's a system installed on board and is propagating a signal called squitter, okay, with information about the plane, okay, and is broadcasted, okay. You can, okay, in the Carlos III University, we have an antenna capable of capturing this ADSB. So, and it's quite cheap, okay? It's 100, I think 100 euros. You can get it a bit more probably. And the ADSC is more advanced technique, okay? The air traffic controller uh, prepare like a contract, like, okay, guy, send me that information. So identification, altitude, speed, well, true speed, every, I don't know, every 10 seconds. And then the aircraft automatically, if there are equipment able to transmit that information, so automatically accept it, that contract, and is sending the information, okay? So I think is a very good technique, and we will see later on, but it's starting being used in some flights. Oh, sorry, the multilateration. Multilateration is a system that uses aircraft transponder transmissions, so the one that I already mentioned, in different modes, okay, mode Alpha or Charlie, mode Sierra, or ADSB, okay, to calculate a 2D or 3D position, okay. It uses a technique known as time differentiate of arrival, okay, to establish surfaces which represent constant differences in distance between the target and the pair of receiving station, and determines the position of the aircraft by the intersection of these surfaces. This is pretty much what I mentioned here. So there is a plane over here, and you have different antennas. Okay, there are different modes of operation, and each antenna creates a surface, okay, that represent, okay, because each antenna is getting like a distance to my plane. Okay, let me use a different color because I think it's very difficult to appreciate. Okay, this is the distance from this antenna. I don't know, I think this is from this antenna, probably this color over here, okay, from that one. And finally, what you are getting is like the position of the plane as an intersection, okay? So radar, yeah, a deeper insight in radar techniques, because that was the typical, the traditional technique used in surveillance, a surveillance system, and is one of the pillars, okay, the technology we have right now or nowadays. And the two that I already mentioned, here I was just adding that and very important, that the primary surveillance radar is non-cooperative. This means that we don't need we don't need any specific equipment on the plane. Okay, it's just so the primary surveillance radar. Just for you to know, this is the one called primary surveillance radar, and this is the secondary surveillance radar. This is typically used in approach because they are used together. Okay, because they are more accurate. They are using other properties, and the signal is configured in a particular way where we are getting more accurate information, okay, with more resolution, and and it's better when there are a lot of traffic, okay. So in the vicinities of the airport is needed, okay, that accuracy in the information. Uh, and yeah, no cooperative way is like there are not any equipment. I mentioned already, not equipment, not the specific equipment, because what we are just collecting with this guy is just the echo. So we are propagating a signal from here, and then what we are reading and interpreting and in order to acquire the aircraft position is just the echo coming from the plane. Okay. But the secondary surveillance radar is different. It's cooperative. Okay, so we interrogate from this guy. Okay, and the plane is preparing a response, and the response is coming in a different frequency and with the information composed by the transponder over here. Okay. So it's a cooperative system. It's more accurate, as you may imagine. There are other advantages. Don't worry, we will dedicate a specific section later on for that. And I want to highlight also that radar technique is also used for the weather radar and for the radio altimeter. Okay, the weather radar is, oh, let me write it down here. So this is the plane. Sorry, you know already that my pictures are very, very bad. Okay, you have here a plane. So the weather radar is located here in the nose. Okay, it's like a plate over there, and is in charge of identifying identifying if here you have storms, okay, in the plane. And also the radio altimeter. The radio altimeter is, so the system is over here. Why? Because the signal is propagated down in order to identify the altitude above the train, okay. Understood? I think we can keep going. Okay, so different applications. So depending of the use of the needs, okay, we are using one surveillance system or another. Okay, for example, in the oceanic areas, so where obviously you cannot allocate a ground system, okay, you only are able to use, okay, procedural, okay, just communication, okay, communication with the air traffic controller, but also a automatic deployment surveillance contract, okay, using satellite, of course, because you don't have like VHF, okay, visual line with the ground infrastructure, okay. En route, well, just for you to notice, this is a SMR, okay, is a surface maneuvering radar, sorry, surface movement radar, okay, and it's typically the technology is like in the primary surveillance radar. Okay, just interrogating just to get the traffic in the surrounded area of the airport. Okay, okay, en route. In route, you have secondary surveillance radar, but this annotation over here is not, by gratitude or it's just because to highlight that you don't need the resolution uh, that you are, demanding in the approach or where are more traffic, because we will see later on that the you know the performance in the signal we are using for the secondary surveillance radar or the radar itself is becoming, different problems, different errors. So also the range of the signal is shorter. So in route where you don't need, I insist on that, accurate 3 nautical miles, like in approach, you can uh, get greater distances, 5 nautical miles typically. You set different performance, okay, in order to get long range distances. In approach, I already said that we install together the primary surveillance radar and the secondary surveillance radar with this high resolution or high accurate information, or higher accurate information, typically used in the TMA, okay, in the surrounded area of the airport, where there are a lot of aircraft and yeah, and traffic climbing and descending to the airport. And yeah, at the airport, finally at the airport, we have like this primary surveillance radar called surface movement radar. And yeah, I want to finish with TCAS. We are also covering in one of the following videos, okay, because we think that this is a system very important and also in surveillance. Is basically a system uh, installed on board. Okay, so this means that we don't need a ground system or ground infrastructure uh, for it. Okay, so it's just collecting from the transponder. So this is our aircraft and this is traffic. So this is also another traffic and another one. Okay, and we are collecting the signal from the transponder where we know, okay, I am Pepito and I am Fulanito. Okay, with this is my speed and depending of the distance among them, so there is a procedure or there is a yeah, one way of actions, and the closer you are, you know severe colors we are using. So red one is dangerous. Okay, so we are entering into the red zone, which is the resolution advisory. Okay, it's like you have to do something in order to avoid a collision, and the amber or yellow is you are in the traffic advisory. Okay, there is some issues. Okay, and you have to notice that the traffic is over there and avoid any possible collision. Again, don't worry about this. So it's important for you to know what are the aspects we are going to cover in this surveillance chapter, which is the primary and secondary surveillance radar, ADS technique a little bit, and finally the traffic collision avoidance system. Okay, I hope you have enjoyed and you have a clear idea of what we are covering here in the surveillance chapter, and I see you in the next videos. Okay.